First step, after of course you write your statements and reasons, which I'm not going to write out the whole word every time. Statements and reasons. Your first step, thank you. Your first step should have been to list your givens. This class is getting a little hostile. Can't we all just get along? I'm going to have to revoke some people's talking privileges. Okay. Now, before we even start looking at this, what do we ask to prove? Who can tell me? Is C parallel to D? What? I said this yesterday a few times. What are the only things we can use to show that? Only stuff we can use to show that is what? Those converses. Those converse theorems from 3.3 are the only thing I've given you that ends with, therefore, blank is parallel to blank. Yeah, right. So, now all of those converses required some kind of angle. Some alternate interior, some corresponding, consecutive interior, alternate exterior. So obviously, somewhere in this picture are varied angles that we can either figure out or need to figure out that will allow us to show one of those converse angle relationships. So CD, that's these two. Which means we're going to have to use one of these transversals, which means we're going to have to either pair up angle 1 and angle 2, or angle 3 and angle 4. That's what we're going to have to do. We can't pair 2 and 4 to show these two lines, because 2 and 4 aren't on these two lines. It's just on this one. We're going to have to use these two or these two. They provided for us that 2 was congruent to 3. Now, knowing that these two lines are parallel, these two, I can now make connections between these angles, between these angles and these angles. Because I know these lines are parallel, so on their transversals, I know things about those angles. What do I know about angle 3 and angle 1? What's that? Yes, they are alternate interior. And because I know that the lines that form them are parallel, which theorem can I use to show something about them? Let me actually back up. What can I show about them? If they're alternate interior, what are they in theory? They're congruent, they're equal. How do we know that? Which theorem says if you have parallel lines, then their alternate interior angles are congruent? Yes, sir. Theorem. Here's the difference. The converse says we know the angles, therefore we know the lines. Well, this time we had the lines, we had to show the angles. When you start with the lines, which is what we're starting with here, you have to use the regular theorem. And that's right. The alternate interior angles theorem states that if A is parallel to B, which it is, then the alternate interior angles are congruent. Therefore, step 2, angle 3 is congruent to angle 1 by the alternate interior angles theorem. What number was that? Not the converse, the regular theorem. What number was that? That wasn't the converse? Angles theorem, yeah. 3.1. Okay. Now, here's what we have. We now have these are congruent, and we now have that these are congruent. Now, brace yourselves. One of the properties we talked about yesterday talked about that if two things were both congruent to the same thing, they're congruent to each other. Now, before we even talk about how we know that, how would it benefit us to know that one is congruent to two? I'll give you a hint. It would be the last step of the proof. Second to last step. Actually, no, it would be the last step. How could it benefit us to know that 1 is congruent to 2. Bearing in mind, we're trying to show these two lines are parallel. What kind of angles are they? Not quite. 3 and 4 would be consecutive. What would 1 and 2 be? They're corresponding. And the corresponding angle converse states that if you have two lines cut by a transversal whose corresponding angles are congruent, then what do I know about those lines? They're parallel, and we would be done with the proof. So, back to how we're going to show that angle 2 is congruent to angle 1. Who can tell me? Who can tell me if two angles are congruent to the same angle, how can I know those two angles are congruent with each other? I use like 10 examples. Remember, I used like the Ford and Paris, Tennessee example between Cameron Donovan and Blake. Yes, sir. You know how I always remember this? I always think of that rapper, one who got shot. Yeah. Yes, the transitive property. I always call it TPOC. If two things are equal to the same thing, then they're equal to each other. So by the transitive property of congruence, I can thus conclude that angle 2 is congruent to angle 1. That's really bad. Congruent. By the transitive property of congruence, TPOC. Now, we just 10 seconds ago talked about how, once we know this, we could finish up the proof. How can we now show that BC is parallel to D? By the way, for finding transitive, you can take any problem off your homework today. Just write that down in the paper. No. What? We're only on section 3-4. Come on, we're almost there. Someone said it a minute ago. They said, "What kind of angles are these?" And then I just said that same thing. Except what? That's right. Corresponding angles. Postulate says that if we know the angles, or if we know the lines, we know the angles. We're going in reverse. So instead of the postulate, we need the converse. Anytime you are showing that lines are parallel, you're using the converse. Okay. The order is so important there between the postulate and the converse. Questions about this proof? We're done with it. We have shown what we were looking to show, and we have verified everything using a theorem, property, or definition, although we didn't need any definitions for this one. And that proof is done. You're going to have one as a bonus today, too. Questions? If nothing else, by your next test, you need to know the difference between the converses and their originals. That is an important thing for you to know. All right, 3.4. Find and use slopes of lines. Don't worry, there's no real theorems today. Today is more of a math day, so if you like more numbers than theorems, you're in luck. 3.4, find and use slopes. Now, I'm going to put some notes up there. You do not have to put them in your postulates and theorems. They can go in your normal notes, like wherever you put formulas. First set of notes. The slope of a line. Really, all you need to write down here, don't write down the whole paragraph. Just write slope equals this formula. Slope equals this formula. That's all you need to write. slope, colon, that formula. Now, one thing that was in your book that I didn't bother putting in here because I didn't think it was worthy of a whole slide was they tried to get you to notice the differences in different slopes. You read a line on a graph like you would read a book. You read it left to right, okay? There are people that are like, hey, there's an arrow going down. This must be going downhill. No, you read it left to right. Is this going up or down, left to right? It's going up. Therefore, it has a positive slope. If it was going down left to right, it would be a negative slope. If it was completely flat, guess what kind of slope that would be? You're right. Mathematically, what kind of slope do you think this would be? You're right. It is zero. Here's how I always think of, well, actually, I'm getting ahead of myself. Let's just write down that formula, and we'll talk about it some more in a second. Everybody got that? All right. Again, you do not have to record that in your postulates. All you really need to do is make sure you write down somewhere in your notes that the slopes of parallel lines are equal. That's the whole basic point of this. The slopes of parallel lines, and you might want to underline the parallel lines, that's the key. The slopes to parallel lines are equal. That is it. The important thing. Yes, bless you. Slopes to parallel lines are equal. Next slide. One second. All right. The slopes of perpendicular lines. Here's what you need to write. The slopes of perpendicular lines multiply and equal -1. When you multiply the slopes of perpendicular lines, keyword being perpendicular, it will always equal exactly -1. Right. Okay. Examples. Find the slope of P and Q. So here we go. Which 2 points lie on line? I'm sorry. Find the slope of Q and R. What 2 points lie on line Q? Here's Q. What are 2 coordinates that lie on Q? That's right, 5, 5, and 8, 7. Now the slope, y2 minus y1 over x2 minus x1. Now you might notice 5, 5 lies on both lines. Actually, there's 4 lines here, isn't there? Well, it lies on 3 lines. So you can use it for any of those lines. And all of those lines. So here we go. Slope, y2 minus y1, the 2 y values, divided by x2 minus x1 equals 2/3. 2 over 3. Done. You found its slope. Order does not matter if. I know some of you are out there thinking, what if I did 5 minus 7 first? It doesn't matter as long as you're consistent. If you're going to use the 7 first, you have to use the 8 first. If you're going to use the 5 first, you have to use the 5 first. Just be consistent, and everything will work out. We found those coordinates from line Q. Here's Q. Here are 2 points on Q. So we use those. So, since you asked, what are 2 points that are on line R? Where's line R? What are 2 points on that line? Yeah. 5, 5, and 0, 5. So, let's do that one. Let's see, that would be, I'll just write it down. 5, 5, and 0, 5. So, y2 minus y1 over x2 minus x1. What's 0 divided by anything? 0. So the slope of that one is 0. A lot of people tend to get confused about horizontal and vertical, about which one's which. Which one is 0 slope, which one is no slope. Here's what I always tell people. When it comes to slope, because also, another thing people get confused is, well, what's steeper? 1/3 or 3? Which one? First of all, it's always rise over run. So this means we're rising 2 units, going over 3 units. That's why it's like over 2, rise 2 over 3, rise 2 over 3. Here's how I remember slope. Slope is like, where do you hear the word slope? Like when you're skiing, right? When you go to ski, like, look, it's a slope. The bigger your slope, the higher your excitement level. If you're on a complete level plane, you're not going to be moving anywhere. Your excitement level is at 0. 0 slope. If it's ever so slightly inclined, your excitement is very low, like 1/5. Really boring. If it's like this, you're freaking out. If you are, and your slope's going to be like 1,000. What if it's completely vertical? Means you're going to die. Which means your excitement levels are off the charts, and that doesn't even have there is no slope for a vertical line. You can't even fathom it. You're just contemplating your end. So, vertical line, no slope. Horizontal line, 0 slope. Try to remember that. Ooh, also, now, please notice you have line, we're going to call this line S, line R, line Q, and line P. Okay? Which of those 4 circled lines has a negative slope? Raise your hand. Which one of those 4 lines has a negative slope? Malik. Very good. Which one has a non-existent slope? Elijah. Close. What's the slope on R? 0. Very good. So which one would have a non-existent slope? P. And which one has the positive slope? Q. Right. 0 slope, non-existent slope. Find the slopes of each line and then say if they're parallel. Try to find the slopes of those 2 lines and then we'll talk about if they're parallel. I'll come around and assist if you need it. Line A. So you needed the points negative 4, 6. And you need the point 0, 3. Now, slope. You take the y values. Now, it doesn't matter which one we start with. You want to start with the 6 or the 3? 3. So you take the 3 minus the 6. All that matters now is you put their x's in the same order. So 0 minus negative 4. So what's 3 minus 6? Negative 3. What is 0 minus negative 4? Positive 4, and your slope is negative 3/4. Slope. For B, you'll take the point 1, 7, kind of out of room here. So 1, 7, and the point 6, 2. Let's do 2 minus 7 on the top. 6 minus 1 on the bottom. Negative 5 over 5 equals negative 1. Now, are they parallel? They have to equal exactly for them to be parallel. Now, when I say exactly, you might have one sometime where you get like 2 over 4 equals 4 over 8. Are those the same thing? Yeah, those would be parallel. But they have to equal the same thing for them to be parallel. So these are not parallel. Not parallel. How would I test to see if they're perpendicular? You can see that they're not, but how would I test it? Multiply them. And what should it equal if they were to be parallel? It should equal negative 1. If I multiply these two, I just get positive 3/4, not negative 1, so they're not parallel or perpendicular. Not that I asked you that. Let's look at another one. All right. Line K passes through those 2 points. Graph the line perpendicular to K that passes through point negative 4, 3. Ooh, I wasn't supposed to show you the graph yet. I guess that's what we were supposed to do. So I won't. Okay. Well, here's how you're going to do this. When you graph it yourself, make your little coordinate plane. Actually, yeah, let's do it like this. Okay. Let's plot those points. For K, negative 1, negative 4. For 3, 6. That's right here. Connect your dots. Ooh, I'm not very good at this, but I'll try. Yeah, I know, but I'm not very good at it. Close enough-ish. Okay, there's the first one. The second one contains which point? Negative 4, 3. So you're thinking, so what do we do with the other point? Just eyeball it? No. To find the slope of your line, you need to find the slope of the first one. And, well, I'll show you. First, let's find the slope of the first one. 6 minus negative 4 equals 3 minus negative 1. So that's 10 over 4. What's that reduce to, somebody? 5 over 2. Now, I told you earlier, if two slopes are perpendicular, they multiply to be negative 1. But what if you're just looking for a perpendicular slope? There's a very, 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 very easy way to find another slope of a perpendicular one. All you do, flip it and change the sign. So the perpendicular slope to this would be negative, since this one's positive, 2 over 5. Now negative, is that going to go down or up? Down. Remember, slope, rise over run. So instead of going up 2 and over 5, I'm going to go down 2 and over 5. Down 1, 2, over 5. Where am I right now? Am I at 3? Yes, I am. No, I'm at negative 4. 1, 2, 3, 4, 5. Connect your dots. Now, my line might not look perfect because I just sketched it. But when you connect your dots, that should be your perpendicular line. And that's how you sketch it accurately. You take your slope and you count. -2, 1, 2, over 5, 1, 2, 3, 4, 5. Connect your dots. They wanted you to sketch it, so that's what you have to do. The key to remember here, to find a perpendicular slope, you just flip it and change the sign. Just flip it and change the sign. Here's a quick thing. We're just going to write down some perpendicular slopes. What would be perpendicular to -3/7? What would be perpendicular to -3/7? Change the sign. So +7/3. You always just change the sign. What would be perpendicular to 1/5? -5/1 or just -5. What about +4? Boom! That's right. Because 4 is over 1, you really just make that -1/4. Those are perpendicular slopes. Perpendicular. Okay? Last slide. Then we're done. Find the slope of the line. Find the slope of the line N perpendicular to line H passing through P. Okay. You then have to graph, but we just graphed one, so we're just going to work on finding the slopes for now. So, all we have to do is what we just did. I need you to find the slope of the line that's given. Find the slope of that line. And then find the perpendicular slope to that line. Let's just do 23 together. Just do 23 right now. Slope. Yes, sir. Oh, do you already have it? Oh, we're going to work it out together, but I'll ask you and see if you got the same thing in a second. Slope. -2 minus 1. If you did it in a different order, it's not going to matter if you did your 1 first. Over -3 minus 3. Equals -3 over -6. And what did you get that to equal? Trip? 1/2. That's what I got too. What would be perpendicular to 1/2, Brandon? What's perpendicular to +1/2? Yeah, you do. Flip it and change the sign. Malik, what's opposite of positive? Negative. And what's opposite of 1/2? -2/1. Boom. There's your perpendicular slope. We can work 25 if you want, if there's questions, or we can move on. If you'd like for us to work 25, raise your hand. All right. Then we shall. All right. Slope. y2 minus y1. Now, how do I know I'm not using point P? Yeah, it's not going through our line. Very good. And then you take 2 minus -5. Are there any questions about why we put them in that particular order? Not that it matters, but as long as it doesn't matter which order, as long as you're consistent. So -4 plus 3 is -1. +2 plus 5 is 7. So your slope is -1/7. Anything gonna cool on? Hey, you got your glasses in. Awesome. Jasmine, what's perpendicular to -1/7? +7/1, or just 7. Very good. Questions? Okay. Here's your assignment. It's kind of a little scattered and all over the place. I apologize, but I didn't want to give you ones that I didn't want to give you. So there you go. That one at the bottom is a bonus. Yes.